session for everyone, just so you know. Okay. So let's go ahead and get that screen shared here in just a second or so, and we'll get going. Okay. And I'll let you guys kind of monitor the screen a little bit for me to make sure it's coming in and all that kind of stuff. Now, what we typically do, we'll ask everyone to just kind of mute their mic until they have a question, and then unmute the mic and ask those good questions. In addition, what we'll do is we'll make sure that towards the end of the day or towards the end of the training session, we'll make it a point to have an open session for questions as well. So if you have a question during the presentation, go ahead and just unmute that mic, and we'll be glad to answer that question on the fly. Or if you want to hold it till the end, we'll have an open forum type of session at the end of the training session so that we can answer those good questions and stuff that you may have accumulated during the class today. So with all that said, let's go ahead and get started then, everyone. So as we take a look at the HMH7, one of the neat things about it, as we take a look at it, we need to remember that even though it looks like a mini split, it is not a mini split. Now, I want to stress that again. It has some of the same compressor technology as a mini split, but it is not a mini split product. And so you'll notice that on the 4 and 5 ton unit, that's going to be the 2-fan model. And on the single fan models, that'll be the 2 and 3 ton product on the single fan models, and the 4 and 5 will be the 2-fan model. In addition, even though they're not mini splits, we're going to hook them up just like a normal heat pump. We are going to have those kind of mini split adapters. In other words, you're going to need an adapter to go from 5/16 of flare fitting on the unit to a 1/4-inch service hose. So those little adapters, those are available from Robinair and JB Industries and stuff. A lot of people make these little adapters, but just make sure the service technicians understand that you have to have that 5/16 to 1/4-inch flare adapter to get these units hooked up to your service hoses. Another great question that we get quite a bit, and this is right inside the install information, the amount of questions that we get quite often concerning, what about the outdoor temperature? What about the indoor temperature? So here's a little chart that I always like to show when we have our introduction, that we actually have an outdoor cooling minimum temperature right out of the box of 35 degrees outdoor cooling temperature, and a maximum up to 122. So there in Indianapolis, I can't imagine it ever getting up to 122 degrees, but still, we do have a real nice broad operating range on that. Another question we get quite a bit is how cool, or not how cool, more specifically, how long will this thing operate, or what can we operate down to when it's cool outside or cold outside? And so our dry bulb heating minimum is actually a -5. So we're still making heat down around 0. In fact, as Tony can provide some charts with you, he can talk to you a little bit about it after the training or during the training. We've actually got ratings on this thing all the way from about 60 degrees down to 0, and it's pretty aggressive. We can get some pretty good heating performance even down into those lower temperatures, 10 degrees, 0, and so on. And so you can kind of take a look at that little chart. Like I said, this is the install information. And of course, if you have more questions on that, we can certainly entertain those as well. So any questions or comments on just the basic overview of what the product looks like, the fact that it is not a mini split, and some of the little tools and things that we're going to have to get our service gauges on there. Any questions or comments? Everybody good? We're good. Okay. What then, let's go ahead and jump into our program. So we're going to be covering the HMH7 heat pump, and this has just been a really, really good product for us. I'll tell you, we started carrying this product a while back. As a matter of fact, Tony has one in his own house, so he could tell you more about it maybe during break or whatever, but he's really enjoying that, and we're seeing a lot of really good feedback and hearing a lot of good feedback from the field. This is just a wonderful piece of equipment. It's very, very versatile. As a matter of fact, we're going to be covering, the installation, some of the installation highlights, so to speak, on all the products that it'll match up with. It'll match up with air handlers. It'll match up with our standard ECM type of motors. It'll match up with furnaces. It'll match up with variable speed products. and it'll do all of that with just simple 24-volt hookup. And that's one of the things I really, really like about this product is the fact that it's very, very easy to hook up, and you use just your favorite heat pump thermostat on the wall. And so we're going to be talking about some of that stuff. So at this time, let's go ahead and discuss that low voltage wiring and setup. And we're going to start out with an AE air handler, which features what we call a standard ECM motor. Now that standard ECM motor is that high efficiency motor that we're going to be seeing in the AE air handler. It's also the type of motor that you'll see in like the TME line of furnaces and the TMY family of furnaces. So this is not a variable speed motor, but it is a high efficiency motor that's going to typically have like 5 speed taps on it. We're going to talk about that low voltage wiring with an AE air handler and with a simplified block wiring diagram. We're going to literally go wire for wire from the thermostat to the indoor unit to the outdoor unit. Now, please remember the AE air handler has no terminals, but is equipped with pigtail connections. So when we start making that block wiring diagram, you're going to see it going to a W terminal or a W2 terminal and so on. Just remember those are pigtail connections on the air handler. In addition, we're going to be discussing the wiring of accessory single pole double throw relay in the indoor unit and how it's used for airflow reduction. Now we're going to recommend kit number HMH7AK001 for convenience and all the supplied parts. So what this kit has, it's going to have a bi-flow filter dryer in there. It's going to have a relay kit and some pre-wired harnessing for convenience. Now, the obvious question comes up if a contractor says, well, I can't get that kit, or that kit's not available. Can I use just a single pole double throw relay with a 24-volt coil? And the answer is absolutely. And could they provide their own bi-flow filter dryer? Well, sure they could. And could they make up all their field wiring, from the motor to the relay and stuff? And the answer, well, of course you could. However, for convenience and supplied parts and ease of installation, we're going to recommend this HMH7AK001 kit. Now, it should be noted that the HMH7A002 kit, and the easy way to remember this, team, is this: the 001 kit is a single or one relay assembly. The 002 kit has 2 relay assemblies on the board. And so the 002 kit may be used. However, if you do use the 002 relay kit on a standard ECM motor product, you will not use the RV relay. In other words, you'll just use one of those relays in that kit. So the 002 kit is kind of a universal kit. You have to have the 002 kit for anything that's variable speed, but you could still use it on an AE air handler in this example. Just remember, you won't use one of the relays. So just a little update on, or a little overview on those kits, and they are recommended for supplied parts and convenience. Finally, your heat pump thermostat, whatever heat pump thermostat you select, your favorite heat pump thermostat, just make sure that heat pump thermostat has a BO selection for reversing valve operation, because our HMH7 heat pump, unlike our other Champion products, it utilizes the B terminal to energize the reversing valve in the heating mode. Let me say that one more time. On the HMH7 heat pump, we're going to energize the B terminal in the heating mode, unlike our other Champion products where we energize the O terminal in the cooling mode. It's not bad, guys, it's just different. So let's just remember that our heat pump thermostat has to be compatible to energize the B terminal in the heating mode of operation. Any questions or comments so far before we jump into actually looking at some block diagrams and seeing how we're going to hook these things up? Any questions or comments?
On that kit, on a TM9 license, today, still use the old one kit.
So the question was, do we have to use that kit? Is that correct?
I'm on a TM9Y. Which kit would you use for that?
So fellas, we're getting a little bit, go ahead.
Oh, he's asking for a TM9Y. Which kit would he use?
Oh, that's an excellent question. On a TM9Y, you're going to use the 001 kit. That's an excellent question. The 001 kit. Good question. Okay, well, team, let's go ahead and jump into those block wiring diagrams. And again, please remember, we're gonna go over every indoor product that this is compatible with, as far as like air handlers and furnaces and variable speed furnaces and so on. So we'll get the opportunity to look at a lot of various things that this thing will work absolutely fine with. Please remember that heat pump thermostat, again, is going to have a B terminal to energize the reversing valve. And so what we're going to do, we're going to take that B terminal from the thermostat. We're going to take it straight outside to the outdoor unit. And it's going to energize the reversing valve anytime we go into the heating mode of operation. And in this example here, we've got a 2-stage, we might have like a 10 or 15 kW, whatever the case may be, heat strip. So we're featuring a 2-stage heat strip in this example. So W2 would be our 2nd stage auxiliary heat terminal from the thermostat to the indoor unit. W1 would be our 1st stage auxiliary heat, and that's going to go from the thermostat to the indoor unit and then outside. Now, one of the things we always got to remember is that when we go into defrost on the outdoor unit, we need to energize some heat strip during defrost, because remember, team, anytime you go into defrost, that heat pump's going into the cooling mode of operation, isn't it? So we want to make sure that we bring a W signal from the outdoor unit and tie it into a heat strip terminal to make sure that we've got a heat strip coming on when we go into the into the defrost mode of operation. So that W going from the outdoor unit back to the indoor unit is to bring the heat strips on during defrost. Now watch this. We're going to get full functionality with just a single Y wire going outside. So even though this HMH7 modulates between 35 and 100% capacity with the intelligence that it has on the board outside, we only have to have a single Y input. And I think that's really, really cool. The fact that we can just use a single stage cooling or a single stage compressor capability on the thermostat to bring the outdoor unit on. So all we need is just a single Y wire going outside for compressor operation. Now, please note, on our AE air handlers, quite often we're going to have a yellow wire. If it's equipped now with it, you may have a yellow wire on the ECM motor. Now go ahead and remove that from the ECM motor. The factory yellow wire on the ECM motor on the AE air handler, if you've got that yellow wire there, if it's so equipped, go ahead and take that wire off, because we're going to wire up that ECM motor with that little relay you see to the right-hand side of that graphic right there. We're going to wire that up in a little differently than we normally would with just a standard application. C terminal from the thermostat is 24-volt common, and that goes from the thermostat to the indoor unit and then out to the outdoor unit. You would expect that. Now watch this. The R terminal from the thermostat is going to hook to R terminal on the air handler, but it does not go outside. Let me say that one more time. We do not take R outside. We don't need it. We don't have to have the R 24-volt outside, because the outdoor unit is going to function perfectly fine without a 24-volt source out there. So it's got all of its own business out there. It's just looking for 24-volt inputs from the thermostat on the Y and the W and so on, and the B and so on. But we do not take R outside with any of the wiring on the HMH7. We just don't need 24 volts outside from the indoor unit and the thermostat. G terminal is going to be our fan call from the thermostat to the indoor unit. Now, this is where we start selecting on the ECM motor. Now, what we're going to do, we're going to select a fan speed. In other words, if the contractor or the homeowner goes over to the thermostat sub-base assembly and they switch the fan from auto to on, how fast is the fan going to run, right? Just fan call all by itself. So the G call on that motor, we want to have it on the lowest speed tap. Now, this is very typical, because what's going to happen if you get a fan-only call on the G terminal or the green wire, what's going to happen, we want that fan to run nice and slow, because more often than not, when the homeowner wants continuous fan, it's because they just want to keep some air moving in the house, nice and slow and gentle, and keeping air moving across that filter. So if they've got some clean air products, maybe an air bear or an electronic air cleaner, we want to make sure that they've got nice slow air, continuous fan moving around if they select that G only call. And so typically, again, on the ECM motor, we recommend that you just select the lowest speed tap, would be speed tap number 1 on a G only call. Any questions or comments so far on the block wiring diagram before we start jumping into the relay and hooking it up and doing some animations and showing you how all that works electrically? Any questions or comments? Is everybody good? Okay. All right, so what we're going to do with that relay, we're going to take one side of the relay coil. It's a 24-volt coil. We're going to take one side of that relay coil and go to S1. Now, S1 is going to be an output from the outdoor unit to switch or to energize that relay when it calls for it. The other side of the relay coil is going to go to common, 24-volt common. So the idea being when S1 is energized outside, it's going to complete that circuit for the A and B, in this example, the A and B terminals, or the coil voltage on the relay. So anytime we energize S1, we're going to switch or energize that relay coil. The common terminal on the switching contacts. The common terminal on the switching contacts, we're going to tie it into the yellow wire or the Y terminal going outside. So basically, anytime we have a call for compressor operation, we're going to provide 24 volts to the common switching terminal. On the ECM motor, we're going to take a wire and we're going to take on high speed tap, typically now, we're going to take anytime we get a W1 call or anytime we get an auxiliary heat call, we're going to take a wire, we're going to field manufacture a wire from the ECM motor speed tap number 5, typically the high speed tap. We're going to go up and we're going to grab that W1, we're going to tie it into that W1. Now here's the idea. Anytime we get an auxiliary heat call or we get a call from the outdoor unit for defrost operation, we're going to drive that indoor motor to high speed. Now, this is, again, very, very typical. We want to make sure that if we're running a heat strip and the outdoor unit, that we're on that high speed tap. And so any questions or comments on that? Okay, good. Now watch this. We're going to take the normally closed contact.
Hold on, Joel. We got a question.
Go ahead. Go ahead, question.
Hold on. We'll interpret, Joe.
Okay, that sounds good.
Joel, the question is, if they're hooking it up on a retro application to an old PSC motor, can we use it, and or how could he?
No, that's a very, very good question. The answer is no. And the reason is because we're going to be commanding on this motor. You're going to see that we're going to be potentially commanding multiple speed taps on this motor. And so an ECM motor, all your ECM motors are designed to where if they get more than one 24-volt input on the speed taps, it just automatically drives to the highest speed tap or the highest command that it's receiving. On a PSC type of blower, you know, you're stuck on just one speed tap or another. So you could have, if you had multiple relays, I mean, you'd have to engineer, you know, multiple relays, you know, so you could have like a G only call and a normally closed 100% call and a 60% call and so on. So you'll see that to try to use a PSC blower, it'd be just about impossible unless you had a 4 or 5 relay pack. You'd have to engineer something like that because the ECM motors, they're designed to where they can take multiple speed commands and they're programmed in such a way that if they have multiple speed commands, they just automatically take the highest command that they see. Whereas a PSC blower, you're locked into one speed at a time. And if you try to energize more than one speed tap on a PSC blower, you'll burn the thing up. So from a practical standpoint, the answer is no. It will not work with a PSC blower from a practical standpoint. So that was an excellent question. Any other good questions or comments?
If we do one of the retro ECM motors, like an Azure motor,
Okay.
replace a PSC, we put it in that one.
Hey, Joel.
Yes.
In that application, the question is if they replace the PSC motor with a, Azure ECM replacement motor, would they be able to use it?
that I could say as long as the coil area was appropriate for the tonnage of the outdoor unit and you know, everything, and you were able to provide the airflow, because you're going to see here in a minute, you know, on that normally closed contact on that relay, we need to be able to set up 100% airflow. So if the coil's large enough inside and it's a good match with the outdoor unit, and we could provide the appropriate airflow, there'd be no reason you couldn't do an aftermarket ECM motor, because even the aftermarket ECM motors, I believe, are designed to where if you have multiple speed taps on them, as long as they're 24-volt speed taps, multiple speed taps on them, I believe they'll work. So the answer is probably, depending on the aftermarket ECM motor. Good question.
Well, what would a matchup on an existing? Joel, can you hear me? Joel, can you hear me?
Go ahead.
What if you're trying to retro this in and you said a proper size coil? So, and would that be if we're going on a copper fence, you go out to half a ton?
Tony or Shane, go ahead and interpret that. I didn't hear real well.
Well, Joel, Andy's asking about, you're asking about the coil size, right? So it's a retrofit. Yeah. Okay, yeah. Okay. You're going to put in one of our coils that would be a match with this? Okay, yeah. So and it's a PSC motor. You think it is? Okay, yeah, so. Sure. So it sounds like, Joel, they're going to replace the coil on this 3-year-old furnace. They believe that the motor, though, is a PSC, and they're going to put an HMH7 on it with a matching indoor coil. And then if they put in an ECM motor, as discussed earlier, then that should be fine, as long as I think that probably the determining factor is the coil a match, and are you moving enough air?
That is correct, Tony. That's an excellent summation. So yes, so the big thing with the HMH7, we let the outdoor unit make decisions on airflow reduction. And so as long as we're able to utilize a relay pack or utilize this control scheme in such a fashion that when the outdoor unit says, hey, I need 60% airflow on that reduced capacity, and you'll see here in a minute with the relay logic that we're going to be using here, that when the outdoor unit says, hey, I need reduced airflow, we have to have the capability of having that motor screw down to 60%, you know, for comfort. And so, so if they do provide an ECM motor in the retrofit that you're talking about with our matching coil on top, to your point, Tony, as long as we're able to provide the proper airflow at the proper time, then there'd be no reason that it wouldn't work. And yeah, that would be a neat application. I'd like to hear more about that, you know, maybe off camera and off training, you know, what you're doing and stuff like that. But there's no reason it would not work that I can think of, as long as we're able to make that airflow reduction and we utilize an ECM type of motor on that. Good questions. Okay, any other good questions, Tony, before we continue with our block wiring diagram?
Nope, let's move on.
Okay, good. All right, team. So you'll notice that on the ECM motor, what we're doing, we've hooked up the relay, and now we're going to take the normally closed contact on that relay, and we're going to take it over, and we're going to hook it up, and we're going to select a motor speed tap on that ECM motor that's going to give us 100% cooling airflow. Now, please write this down or make a note of this. We always want to make sure and provide 400 CFM per ton of cooling based on the outdoor unit capacity. So if I've got a 2-ton unit outside, this 100% cooling airflow speed tap that I'm going to be selecting on this normally closed contact on the relay needs to be 800 CFM. If I have a 3-ton unit setting outside, I need 1200 CFM. You cats get the idea. So we're going to be designing this for 400 CFM per ton of cooling. So we want to make sure that our ductwork will provide or give us the adequate ductwork size and so on for 400 CFM per ton. So when we select this first speed tap on the normally closed contact of this relay, we're going to take a wire from the normally closed contact. We're going to go over to the ECM motor, and we're going to select a speed tap to give me 100% airflow at 400 CFM per ton of cooling capacity. On the normally open contact of the relay, we're going to go over and we're going to grab a speed tap on the ECM motor that's going to provide 60 to 65% airflow. Now, I've had some questions from the field say, well, Joel, you know, I'm working on this AE air handler, and a speed tap number 4 gives me 100% airflow for cooling. Okay, that's fine. But speed tap number 3 on a 2-ton unit, we'll say a speed tap number 3 gave me 950 CFM, and speed tap number 2 gave me 785. I'm just making that up. And so the point is, we want to make sure and select a speed tap as close as we can get, to the airflow we're looking at, because sometimes this isn't very precise. But let's say, for instance, I've got a choice between 55 to 60% airflow on low speed tap, or I have a choice between 75 and 80% on low speed tap. Well, team, I'm going to select the one that's going to give me 50 to 50 or 55 to 60% airflow. So the point is that we're saying 60 to 65% airflow on that low speed tap. But if it happens to be 55%, I'm okay with that. So there's a little fudge factor both ways, with a nominal or middle number of about 60% on that low speed tap, and then high speed 100% airflow, or as close as we can get to it. Any questions or comments on that? Everybody good? Okay, good. Because like I said, sometimes when you're setting up your airflow and you're looking at your static pressure and you're looking at your airflow charts, you know, we want you to get as close as possible to 100% airflow on that normally closed contact, and as close as you can get to 60 to 65% airflow on the normally open contact on the relay. Okay, so some considerations as we start taking a look at this a little bit more. Let me do that animation again. So what's going to happen when the outdoor unit starts going into reduced capacity outside, it's going to generate an S1 signal. That's a 24-volt signal from the outdoor unit. It's going to energize and switch that relay, and it's going to command low airflow on that 60 to 65% airflow tap. So let me back up one more time. So right now it's 100% airflow. You're cooking along 100% airflow. The outdoor unit says, hey, I'm in reduced capacity. I need reduced airflow. And bang, it energizes that S1 contact, or that S1 output. We energize that relay. We switch that relay, and we go to that reduced airflow on the ECM motor. So any questions or comments on that relay logic? You kind of watch the animation. So we're letting the outdoor unit decide when we go to reduced airflow based on its point of capacity outside. Very, very simple, very straightforward, but it's going to give us a wonderful level of comfort, because now we can actually reduce our airflow inside as that outdoor unit starts screwing down its capacity. And remember, team, that outdoor unit modulates between 35 and 100% capacity. When it starts getting down around that, 60, 65, 55, whatever percent capacity, it's going to switch that relay and have reduced airflow inside to help match that comfort need at that reduced capacity. Any questions or comments on how that works? Everybody good?
Hold on, George.
So Joel, the question is, if they have to use it with a dehumidification contact on the stat, would it slow it down, or could you wire it? Hold on.
All right. So if you have dehumidification functionality on the thermostat, what's going to happen is that the thermostat, if you have it in the dehum mode, typically most thermostats that have dehumidification, what it will do, it will allow you, as long as you've got a Y column for compressor operation, it will allow the thermostat to overshoot the set point, 1 or 2 degrees. So if it's humid in the house, it'll just allow the unit to continue to run, is how most thermostats will do that. So with that scheme, with that wiring scheme that we have right now, so the outdoor unit's reducing airflow capacity based on its point of capacity. But the thermostat itself, if it wants to dehumidify based on the thermostat design, most thermostats that control humidity, they just overshoot or they overcool the space slightly if it's humid. And so that would still work fine with this scheme, as far as the thermostat, controlling how long the runtime is, basically based on the humidity level in the space. So that would still work okay. Good question. Any other good questions?
I think we're good, Joel.
Okay, good. All right. Now we're going to notice something, team. If there's a W1 call, anytime we have a W call or W1 call, what's going to happen is the ECM motor is going to go to high speed. And S1, if we happen to be in reduced capacity, S1 would have no effect. So in other words, if I add an auxiliary heat call on top of what this indoor motor is doing, it's always going to take, the ECM motor is always going to take the highest speed command it's receiving. So if I should get an auxiliary heat call, even if I have an S1 reduced airflow condition, and I get a W1, or if I get an auxiliary heat call, bang, it's going to go ahead and go to that high speed because we're getting a W1 call. In addition, please remember the W1 will be present with a thermostat auxiliary heat call or during defrost cycle. So let's say this thing was in reduced capacity, it's in the heating mode, it's in an S1 call, then bang, all of a sudden we go into defrost, it'll drive that indoor motor to high speed. So just please remember those points with the ECM motor. If it sees a multiple speed command, it will always take the highest speed command that it's receiving. Any questions or comments before we move into some other products and so forth?
We're good, Joel.
Everybody good?
Yep.
All right, team. Well, at this time, let's talk a little bit about those standard ECM furnaces. And some examples that you'd have with a standard ECM type of furnace blower product inside would be like a TME family of furnaces, like a TM8E or TM9E furnace, or a TMY family of furnace, which would be like a TM9Y or a TM8Y. Those furnaces feature a standard ECM motor, and we're going to use the same relay kit we just talked about. So we're going to be looking at the low voltage wiring with those two furnaces and simplified block wiring diagram again. Please remember the TMY is a two-stage furnace and the TME is a single-stage furnace. Now, please write this down or put this in your hip pocket. The TME furnace, even though it's a single-stage family of furnaces, it still has two-stage cooling capability. Isn't that neat? So let me say that one more time. The TME furnace, even though it's single-stage heating, is two-stage cooling capable. Same way with the TMY furnace. The TMY furnace is a two-stage heating furnace and a two-stage cooling capable furnace as well. So I really like that little TME furnace. It's a great little furnace, and a lot of times our customers don't realize that even though it's single-stage heat, it does have the capability of two-stage cooling capability, which I think is pretty neat. So we're going to be talking about that wiring accessory kit again. That HMH7AK001 will be recommended for supplied parts and convenience, and it's that single pole double throw, just a single pole double throw relay arrangement. And remember, team, also on your heat pump thermostat, we still have to have that BO selection for reversing valve operation. In addition, if you're going to be hooking this heat pump up to a furnace, we have to please remember that heat pump thermostat has to have dual fuel function when you're going to use it with the furnace product. And so make sure that you select a thermostat that has not only the BO selection for the reversing valve, but also that your furnace, the heat pump thermostat that you select needs to have the capability of dual fuel function if you're going to be hooking it up to a furnace. Oh, here we go. Let's take a look at this TME family of furnaces. That would be like a TM9 or a TM80 single stage heating furnace with the HMH7 outside and a compatible thermostat on the wall. So team, just like before, we're going to have that B terminal going outside to energize the reversing valve in the heating mode of operation. And that thermostat has got to have that BO selection. Now, because this is a single stage heating furnace, we're just going to have that single W terminal on the furnace. And by the way, on the furnaces, we have hard screw terminals. There's actually screw terminals on the board for your 24-volt wiring. So W1 from the thermostat will go to W on that single stage furnace, heating furnace, and then W outside to the outdoor unit. The Y terminal is going to go straight outside, like we said before. We're going to have we will have some connections on the relay inside the furnace, but a Y goes to Y outside. That's our compressor call. Is our 24-volt common all the way through, just like we had before. This probably looks familiar because it's very similar to what we just did on the air handlers, except it's a furnace product now. Ours is 24-volt hot, and it does not go outside, just like before. G's our fan call. And as we take a look at our relay, we'll see that one side of the relay will go up to one side of the relay coil. I should specify one side of the relay coil will go up to that S1, just like we had before. The other side of the relay coil will go to 24-volt common so that we can complete that circuit for the relay coil. Now, the common terminal of the switching contacts, we're going to take Y terminal like we did before, and we're going to provide, anytime we have a compressor call, we'll have 24 volts to the common terminal of the switching contacts on the relay. The normally closed will go up to Y/Y2, because remember, even though this is a single stage heating, the board is capable of two-stage cooling, or two-stage input for cooling. So normally closed contact will go up to Y/Y2 on the board. And then the normally open contact on the relay will go to Y1. Now remember, team, when you're setting up this TME furnace, you're still going to have to go in and select on the motor, your high cool, low cool. You're going to have to be sure and select the proper speed tap on that motor for 100% airflow on Y/Y2 and 60% airflow on Y1, that first stage or that low stage cool. Now, as we take a look at that block diagram, is there any questions or comments on it?
We're good.
Okay. Well, watch this. This makes things really simple. The TMY furnace wires exactly like the TME, exactly, except the TMY furnace has got two stages of heat, and so we have a W2 and a W1, basically. It has two stages of heat, but everything else wires exactly the same. Isn't that cool? It's very, very simple. It's just straightforward. Wires exactly like the TME, except now we're dealing with a W2 and a W/W1. So let's go ahead and tie those in. W2 would be your second stage heat on the TMY, and W1 would be your first stage heat, and that's going to carry all the way through outside so that we can have that first stage of heat strip coming on during defrost if we go into defrost outside. So other than that, it wires the same, the relay is the same, very, very straightforward. Now, as we animate this a little bit, we see that just like we had before on our standard furnaces, our ECM motor furnaces, when I energize S1, it's going to energize that relay. It's going to switch from high airflow to low airflow. So that relay, what it's really doing, and this is easy for us to kind of get our heads around, what S1 is doing outside when it's in reduced capacity, it's commanding that relay inside to go from high speed airflow to 60% airflow whenever we get an S1 input from the outdoor unit. Any questions or comments on the simplified block wiring diagram and the relay logic that we have with that 001 kit on the TMY and the TME furnace product, as we've just described in our training just now? Any questions or comments on that?
One question. When you do a two-stage furnace and you take these boards on and let that control the stage on the heating side, you
have to use W2 off the stack.
You hear that, Joe?
I did not. Go ahead.
He's asking if you have to use both W1 and W2.
Well, on a TMY furnace for ultimate comfort, you know, we're going to want to have those 2 stages of heat. But if you were in a situation where you didn't have enough wires or something, you could jumper W1 and W2 at the furnace. And what would happen is that the furnace would see that as a simultaneous command for both high and low stages of heat. And at that point, it would drive it to high speed or high airflow. High heating every time. And so we're going to recommend that you use a 2-stage heat thermostat if you're going to be having a 2-stage product inside, because that'll give you the best comfort. Because you know your first stage auxiliary heat on that 2-stage furnace is about 50 to 60, maybe 65% heating capacity. And on those mild days, you wouldn't want to be blasting all that heat in there unless that's the whole idea behind a 2-stage gas furnace, is it gives you better comfort. So could you do it? Yeah. Would we recommend it? No.
So Joel, I think used to the board there was a time, if you wired it up that way on a single stage stat, the board would have a timing mechanism that would come into play. It's not the same effect as a 2-stage stat. It'd be sensing temperature, but does the control still have that functionality?
It does, and thank you for that great question, Tony. There's actually 4 selections on the TMY furnace. On the TMY furnace, you've got 4 selections. You've got auto, you've got 10, and you've got 15, I believe, and then off. If it's off, it ignores that function altogether. In the auto position, what happens if it sees a W/W1 call in the auto position? It starts monitoring the furnace board now monitors thermostat activity, and it'll make intelligent decisions on staging, because it'll look at history, it'll learn, what those cycle rates are, and then it'll start making intelligent decisions on when to go to W2 or second stage. When it's in the 10-minute or the 10 position, it'll automatically, if it has a W1 call, 10 minutes later, it'll go ahead and go to W2 until the thermostat satisfies. And then, of course, in the 15-minute, I think it's the 15-minute position, it'll do the same thing. It'll see a W1 call 15 minutes later. If it sees that the thermostat's not satisfied, it'll go ahead and go to second stage until to satisfy the thermostat. So yes, there are some functionalities on the TMY furnace board level that if you're stuck with a single stage thermostat, you can still get some staging, but it'll be a furnace board level intelligence. Good question. So again, if you're stuck with that, you can do that, or like I said, if you want all the heat at the same time, you could jumper W1 and W2, and then the furnace would just interpret that as a give me high furnace capacity every time you get a W call. So there would be a couple different options there at the furnace board level if you wanted to do those. Excellent question.
The wires, you don't have enough wires, maybe probably. Yeah.
We don't have to.
Yeah.
Yeah. So on the TMY furnace, you do have some options at the furnace board level. If you do have, if you're just stuck with, not enough wires. So yes, it can be done. You'll have some nice functionality if you need to.
Yeah. So the another question was, Joel, that as we ship it from the factory, doesn't it come in that automatic position?
Well, you're making me plug in my third brain cell, Tony. Let me think for 2 seconds here. Yes.
I'm pretty sure it does. Yeah. Because we've always kind of, we've that's kind of a feature of the furnace. So yeah.
Yes, you are correct. So the factory default should be in the auto position on those dip switches. That does sound correct.
Okay. Any other questions? Yeah. Okay.
Sounds good. Okay. Well, team, let's take a look at some variable speed products now. And so at this time, we're going to discuss the ABC air handler and the TMV furnace, which are going to be variable speed. Now remember, team, on the variable speed products, you have to have the 002 kit. So we're going to be looking at the block wiring diagram like we did before. Now, I would like everyone to note that some of the terminals that we're not going to be using for the outdoor unit, we're not going to discuss today. To give an example, you know, the Hume terminal has nothing to do with the outdoor unit, so I don't have that on the block diagram. The D-Hume terminal and the electronic air cleaner, the EAC terminals, has nothing to do with the outdoor unit, so I haven't put those on the block diagram just to kind of keep it simplified for today. So we're not going to talk about D-Hume and Hume and EAC and all that stuff with the functionality on the block diagram today. Please note one more time, the wiring accessory relay kit HMH7AK002 is required for the variable speed product. You have to have the 002 kit because it's got 2 relays on there. We're going to utilize 2 relays for the functionality of the variable speed product. They're going to be designated RV and S1 on the relay pack. Again, heat pump thermostat with the BO selection is going to be necessary if you're going to be hooking it up to a furnace product, and you're going to select the heat pump thermostat with dual fuel function as well on the furnace product if you have a dual fuel function. Okay, so let's start out with an ABC air handler. And we're going to say that we've got a 2-stage heat strip in there. And you're going to notice that we've got 2 relays at the bottom. Now, these are not exact pictures of the relays. That may be a revision we'll do one day, is get an actual picture of that relay board. But you'll get the idea. Electrically, these relays are going to be working like we're going to be showing you as in the graphic today on the PowerPoint. So team, just like we had before, B is going to go outside. That'll be reversing valve is going to be energized in the heating mode of operation on the heat pump. W2 will be our auxiliary heat call, second stage. W2 is second stage auxiliary heat call. W1 will be our first stage auxiliary heat call, and that's going to go outside as well so that during defrost we can bring on that first stage of auxiliary heat during defrost. Because remember, team, that heat pump, when it goes into defrost, what does it do? It goes into the cooling mode, right? I terminal is going to go outside for our compressor call. You're going to notice that this is very similar to our other block diagrams, but we'll just continue to take it wire for wire. C goes outside just like before, 24-volt common. R terminal goes to the indoor unit, but it does not go outside. And then G is our fan call. Now, as we start wiring this thing up, you're going to notice it's going to look very similar to what we did before, except we have 2 relays, and we're going to talk about that RV relay, that additional relay, as we start getting into some of the functionality of the variable speed products. So you're going to notice that one side of both relay coils are going to go to 24-volt common because they're 24-volt coils on these relays. On the S1 relay, now remember, team, the S1 relay is going to be our airflow reduction relay. We call it the S1 relay. The other side of the relay coil on the S1 relay is going to go to S1 just like we had before. So this looks real similar to you, I'm sure, because it's what we've done before on our airflow reduction relay. We're just calling it S1 now on our variable speed product, but the S1 relay is exactly what we've been doing before. We're just calling it S1 now for airflow reduction relay. The common switching terminal on the S1 relay goes to Y just like before. The normally closed contact on the S1 relay goes to Y/Y2. Normally open S1 contact goes to Y1, which makes perfect sense. That's our airflow reduction relay, just like we had before. Y1's our low speed airflow, Y2 is our high speed airflow. Now watch this. The B terminal, or the other side of the relay coil on the RV relay, goes up and ties onto the B terminal, up to the B terminal. when the energized reverse. Or when you energize the reversing valve in heating mode. So here's the logic on the RV relay. Anytime we go into the heating mode of operation, we're going to energize and switch the contacts on the RV relay. Now watch this. The common terminal on the RV relay, the common switching contact terminal, goes up and ties onto that yellow wire going outside for compressor operation as well. So anytime we have compressor operation, we're going to have 24 volts on the common switching terminal of both relays. The normally closed contact on the RV relay is going to go up and tie onto the O terminal on the board. Now, here's why we have to do this. On a variable speed anything, variable speed air handler, variable speed furnace, if we have a variable speed motor in the product inside, the indoor product, during the cooling mode of operation, we have to have, if we're hooked up to a heat pump outside, during the cooling mode of operation, we have to energize the O terminal. We have to energize the O terminal on the indoor product, variable speed product, in the cooling mode, because what that does is it tells the board inside on the indoor product that we're in the cooling mode of operation for advanced functions. One of those advanced functions are what we call cooling on delay. So we've got some options on our variable speed product that when we're in the cooling mode of operation, we can delay the fan from coming on full speed to increase the dehumidification capability. So now we have this ramping operation in the cooling mode, we call it cool on delay, that we can ramp that fan to draw extra moisture out of the air every time it goes into the cooling mode. In addition, that O terminal on the indoor unit, you're telling the indoor unit, hey, I'm in the cooling mode of operation when it's energized. That O terminal also enables what we call a dehumidification function on the indoor variable speed product. So we have to have that O terminal in the cooling mode to tell the indoor unit, hey, we're in the cooling mode for some of these advanced dehumidification functions that I've just mentioned. Now, when we go into the heating mode of operation, we're going to energize that RV relay in the heating mode from that B terminal on the thermostat, which is going to tell the reversing valve outside, hey, we're in the heating mode. But we're also going to energize that RV relay, and we're going to break that O signal. And then now that tells the indoor product, hey, we're in the heating mode. And we don't have that cooling on delay and that cool dehumidification function now because we broke that O terminal. So the RV relay, the only thing the RV relay does, team, is it tells the unit if you're either in the heating or cooling mode via that O terminal for some advanced functions. We're going to switch. We'll do some animations here in a little bit on the PowerPoint so you can kind of get an idea on the switching contacts and what it's doing. But that's the summary of it. That RV relay, the only thing it does is it switches and energizes the O terminal on the indoor product in the heating or cooling mode for some advanced functions on that O terminal. Any questions or comments so far? Everybody good?
Yep.
Okay. So as we go and we take a look at a TMV family of furnaces, it's a two-stage furnace, variable speed indoor blower. It wires exactly like an ABC air handler. It wires exactly like the air handler. The only difference is the terminals, the heating terminals, the auxiliary heat terminals, the heating terminals are slightly different in how they're labeled. So we have a W2 for second stage auxiliary heat and a W/W1 for first stage gas heat, right? So it wires exactly like we did before. It's just the terminals are a little bit different. They're labeled a little bit differently on the furnace than they are on the air handler. Now, as we take a look, one thing I'd like to please remind everybody that if you are hooking this up to a furnace product, you have to have a dual fuel capable thermostat, heat pump thermostat, if you're going to hook it up to a furnace product. Well, let's go ahead and do some animations. Let's do our airflow animation first. Bang, you will notice that when we are commanding reduced airflow, let me back up and do that one more time. When we're commanding reduced airflow from the outdoor unit, we're going to switch S1 relay. S1 relay is our reduced airflow. So we're going to reduce that, and we're going to be energizing Y1, and we're going to be breaking Y2. When we have that animation again, S1 calls for reduced airflow. Bang, what it does, it switches the S1 relay, and it gives us our reduced airflow when it's calling for less capacity outside. Now, when we go into the heating mode of operation, watch the RV relay on the left-hand side, the animation again, one more time. When we energize the B terminal on the thermostat for reversing valve operation in the heating mode outside, bang, we're also going to energize, or we're going to switch the RV relay. And you'll notice right now we're going to break that O terminal on the RV relay, and we're going to tell the indoor unit we're in the heating mode of operation. So anytime we go into the heating mode of operation, by energizing that B terminal that goes outside, we're going to switch that relay, that RV relay. We're going to break that O signal, and we let the air handler or the variable speed indoor product, whether it's a furnace or an air handler, variable speed, we let it know that it's now in the heating mode of operation, and we break that O signal. Any questions or comments on the relay logic, how we're going to reduce airflow, and how that RV relay breaks that O terminal in the heating mode of operation on our variable speed products? Any questions or comments on that?
Good question, Joe.
Yes.
Yeah, the question is about using an outdoor sensor, and I know that's what's recommended, right, Joel?
Yeah, because that's a good question. So because we're driving our dual fuel function from the thermostat level, most of your higher end thermostats will utilize an outdoor sensor for the thermostat, for the switchover point and to do all that on a dual fuel. But some of the top end thermostats I've seen lately, within the last few years, I think Honeywell and maybe Robert Shaw has some. They actually have a they go out and they look at the weather on Wi-Fi and determine what the temperature is outside. So based on your thermostat, you may end up using an outdoor sensor, which is definitely recommended. Or if you've got that Wi-Fi capability where your thermostat knows the local temperature from the weather station input or whatever, that's acceptable too. The main thing is we want to make sure and have a when you're setting up your balance point and all that stuff, it's a good idea to have some methodology of knowing what your outdoor temperature is, so your thermostat can make an intelligent decision on, when I'm going to be on gas furnace or heat pump and balance point and all that stuff. So good question. Excellent. Any other good questions or comments so far? Okay. Well, team, one of the things I'd like to do also, as we kind of start heading towards the conclusion of our training today, is some airflow considerations. Now, please remember, on every install, we want to confirm proper airflow. The HMH7 is a modulating capacity unit, and nominal airflow is going to be very, very important. We want to make sure and size our ductwork to provide 400 CFM per ton of total capacity. In addition, we want to make sure that that we provide that 100% airflow when we have 100% airflow call, and then 60% when we have that reduced airflow. But it's important that we have proper airflow on the HMH7. And one of the reasons it becomes so critical, especially on modulating equipment, and this is really a good general statement for any modulating equipment, that the HMH7, what it's doing, it has multiple sensors on the outdoor unit. Those sensors are going to be looking at outdoor ambient temperature. It's going to be looking at suction line temperature. It's going to be looking at suction pressure. It's going to be looking at liquid line temperature. It's going to be looking at discharge line temperature. So by looking at all of these temperatures, the outdoor unit knows at what point of capacity it needs to modulate to. So think about this for a second. Let's say we have an undersized duct system, or we have a dirty indoor coil, or maybe the homeowner put in some pleated filters. For whatever reason, we've got reduced airflow on the evaporator. What's going to happen is the outdoor unit's going to see a reduction in suction pressure, suction temperature, liquid line temperature, and it's going to say, hey, I have a reduction in capacity inside. I don't need as much capacity. So if it sees the indoor coil freezing up or whatever because you have lousy airflow, what's it going to do? It's going to start modulating back. And so we want to make sure we provide the proper airflow across that indoor coil. We got to make sure the indoor coil is nice and clean and all that. This is all just good service practice anyway. But it becomes more important on modulating systems because the modulating intelligence on that board is looking at all these different refrigeration cycle parameters to determine its point of capacity modulation. So we have to make sure we have the proper airflow inside, and we likewise outside. We want to make sure and keep the coil clean, and do our yearly clean and check and all that kind of stuff, and keep the weeds away from it, so that the outdoor unit can have proper airflow as well. So it just becomes really important with modulating stuff if you want them to work properly. In addition, on the indoor unit, Manual D, we'll go ahead and refer to Manual D real quick, also addresses recommended velocity in duct system components. So if you don't have a Manual D, you can certainly look it up online, but this is a table right out of Manual D, and we actually talk a lot about this in our airflow and duct design class. But some examples would be, when you start building your duct system, try to stay, work hard to stay within those velocity recommendations as well when you build that duct system. To give an example, on your main trunk, coming off the unit, it's recommended you have about 700 feet a minute velocity going down that trunk, not to exceed 900. And then your return trunk, your main trunk coming back about 600, not to exceed 700, and so on. So this velocity table that you can see in Manual D is what we recommend when you're building your duct system to make sure you don't exceed those velocities. You'll see there's going to be branch duct or takeoff velocity recommendations, as well as registers and grills and diffusers. And so we're going to definitely recommend that when you build a duct system, consider your total airflow, but also consider the speed or how fast that air is moving down the duct system, because that's going to affect as well how the unit's going to perform. Now, one of the things we always want to recommend is pay particular attention to, especially Tony, in some of your southern areas down there where they have just a single return and a return grill, like down in Florida, maybe they'll have an air handler sitting in a closet or something, and they've just got one filter grill. That if you do have a filter grill, or return grill with a filter in it, make sure you don't exceed. Manual D recommends you do not exceed a maximum face velocity on that filter of 300 feet a minute. So these are all important considerations when you're building those duct systems out. And as I said, kind of in summary, that when you're dealing with modulating equipment, you want to make sure that you hit those target numbers as far as airflow and velocity and duct design and stuff like that, because if you don't, that modulating unit's going to, if it sees reduced airflow, or if it sees a iced up coil or something like that, it's going to interpret that as a reduced capacity, and it's going to start screwing down its capacity like it's designed to do. And then, of course, if it's a hot day outside and you have an iced coil and it's a hot day outside, the last thing you want is reduced capacity. So please keep those considerations in mind when you're putting these in, that that airflow becomes a very, very important factor and component of the installation. So with that, let's go ahead and open the floor up for any final questions or comments. As a matter of fact, at this point in time, what I normally do is I'll go ahead and stop the PowerPoint, and we'll go ahead and just to kind of open the floor up, and let me turn my camera back on so you can see my mug, and let's open the floor up for a minute or two for any questions or comments as we start winding down our training for this morning.
Good job, Joe. You want to stop the recording now?
I can stop the recording right now. Let me go ahead and do that.